and I would like to welcome all of you to Up and Running with Git. So, in essence, this talk will be about Git and GitHub in general, trying to understand what version control is and why it's absolutely essential for you to know as someone who's going to, work with software and code and hopefully write a good amount of code in the very near future. So yeah, hi guys. If you want to, you can say a hi or something in the chat. I'm just trying to. My goal for this session is to keep it a two-way session, not just like I'm talking and you guys are listening kind of thing. So that's why please feel free to interrupt at any point if you guys have questions. If you guys have anything you'd like to ask in general. I don't want it to be like a completely one-way thing. So feel free to drop it in the chat if you have any questions. Great. So here's a little bit about me. I am a computer science student in my first semester at PES University Electronic City campus. I love learning by breaking things, much to the disappointment of my parents. And I am, as of now, interested in distributed systems and databases from a research perspective. My GitHub username is at Anirudh Rowjee. My website, blog, and my email ID and LinkedIn are all listed here. If you guys want, maybe we can drop it in the chat so that you guys can keep it for reference later, or we'll just send out the slide deck if it's feasible. Cool. So, yeah, what we'll be covering in this session are these three basic concepts. Right? The first is what is Git, trying to understand the technology at the core of what we're doing here. The second thing is basics of Git, which we'll do by showing you some commands and a live demonstration of how you can use Git. And the third part is GitHub. So we'll mostly cover this, unless of course something drags on for too long and we have no time. But mostly we will be covering GitHub. So like we'll show you what it is to create a project on GitHub and how you can put your code there and how you can open a merge request basically on your own repository for you to learn how the process works from both sides. Cool. Everyone's clear till here? Do we have any questions? All right. Okay, cool. Let's move on. So I'm sure this is a question that many of you have had, right? People keep talking about Git and GitHub, and they're always complaining about merge conflicts and talking about pull requests and issues. So today the goal is that we understand what's going on right now when they talk about these things. Going by the definition of it, Git is a distributed version control system. So a lot of big complicated words and not words that you exactly need to understand right now, but the crucial part of it is version control. So it helps you essentially version your code. Like when you're editing, say if you worked on a design project or basically anything that needs to be saved, I'm sure you've come across a situation where you've saved it as copy one, copy two, final, then final, and then like after an hour and 3 cups of coffee, final. So this is something that helps us deal with that kind of a situation. So why is Git useful to us? It helps us track changes that we make to our own files, and if you mess something up, you can move to a previous version of the file. That is one thing that usually is a key advantage, because as humans we make mistakes, and that's completely fine. We just need a tool that will help us, get the best experience out of those constraints as well. The second thing is we can isolate changes that we make. So you can work on multiple versions of the code at the same time, or whatever project it is. You can have a separation of concerns, and like multiple people can work on it at the same time. And the last thing is that it helps you manage changes. So it's a very comprehensive framework through which you can use to decide which is the next feature, which is the development version of the code. A lot of these things might not be very obvious right now, but as you spend more time using it, this kind of stuff becomes more intuitive. So there's nothing to be worried about if you aren't getting the 100% data dump from this right now. Do we have any questions? I hope we're all clear up till this point. Yeah. Okay. If you have a question, please just feel free to drop it in the chat at any time, or unmute yourself and ask. No problem at all. Cool. So why to make it slightly easier to understand, let's consider a more real life scenario. Everyone likes to eat, right? I know I do. I actually just had lunch. So and that's cool. That's completely fine. However, since we want to be self-sustaining, which is an important skill in the modern day world, it's extremely important for us to know how to feed ourselves. This is why we sat down and all of us just decided collectively that we would maintain all the recipes we know in a cookbook. So our smallest logical unit here is going to be the cookbook, right? Which is nothing but a collection of recipes. You can further think of recipes as a collection of ingredients. And you can organize them however you want. It does not affect our consideration of the cookbook here. Are we clear on this so far? Does anyone have any questions? I'll just repeat the essential point is that since we all like to eat and we all want to feed ourselves and be self-sustainable, we've decided to maintain a cookbook. So any questions? Unmute yourself and ask them if you want, or feel free to drop it in the chat. As of now, this is just an example to try and understand what Git is better. So I'm just using the cookbook as an example of sorts or like an analogy of sorts to help everyone understand what it is we're talking about. So do we have any questions? I'm guessing not. Cool, great. The what usually happens is that we have a lot of recipes, more than one at once, if we're serious about eating or about maintaining recipes. So yeah, the summary of this slide is that we have cookbooks that we maintain, and we have recipes that go inside the cookbooks. You can organize these recipes however you want. That's completely up to you. So yeah. So alongside the cookbook, because you're very meticulous, right? So now you have your cookbook, and your cookbook is where you organize your recipes and store them as you want to. So how do you handle making a change to this cookbook, right? For simplicity's sake, let's assume you're using a ring binder to store all the recipes you have. So your cookbook is nothing but like a giant ring binder, and you write down all your recipes on paper, and you punch a hole in the paper that you want to add to the cookbook, and you add that sheet to the book. So now, is this clear? Does anyone have any questions? All right, cool. Cool. So, being the meticulous person you are, right? Whenever you make a change, you write it down in a logbook. So, the logbook is where you essentially capture the contents of your recipe book each time you make a change to it. So, like you write down, whenever you add a new recipe, right? You write down, okay, at this point of time, the cookbook had all these things, all these recipes, and each of these recipes is this. And to this, I'm adding a new recipe right now, and you write all this down in the logbook whenever you make a change. So yeah, you write down everything, such as what the recipes were at that point and how you organize them. So this does seem like a lot of work, and I'm not going to lie, but the advantage, the whole point of doing this is that whenever you make a mistake, right, you can easily go back to that specific point in the logs or in the logbook to see what the cookbook was at that point. So like essentially you're taking a snapshot of the cookbook in time. It's like the cookbook is frozen in time for that particular moment where you added the thing. So that whenever you want to, right, you can refer to the logbook to see what the state of the cookbook was at that point. So you have a starting point essentially to revert to. It sounds like tedious work, yes, but the advantages far outweigh the amount of work required. Does anyone have any questions? This is a pretty complicated concept. So like if you have any doubts, it's better to resolve them right now instead of letting it compound and build into a much bigger doubt. So please feel free to ask questions.
Could you explain the whole time travel part again?
Sure. So the idea is that whenever you maintain a logbook, right, which is what we're focusing on right now, whenever you maintain a logbook contains like a detailed history of what the whole cookbook was at any point of time. So whenever you make a change, you write it down in the logbook. You say the state of the state of the cookbook was this at this point in time, and to that I'm adding these things. So that's what the logbook contains essentially. So when you start off, it will have an empty state, and you say for the first change that you make, you say this is the state of the cookbook at this point. I am adding these things. So that becomes the new state of the cookbook, and you write all this down in the logbook. Think about it as like a history of sorts. Does that help clarify it?
Yeah, it's clarified. Thank you.
Okay, cool. Any other questions? What happens to the logbook if you change something in the past? That's an excellent question. As of now, I do believe we come across something like that a little bit later. But as of now, we're just going to consider that things in the past can't be changed. Like your logbook is write only, so to say. Like you can't change stuff that's already there. It's kind of like a static record of everything that's happened. We will cover something similar in a bit, so I hope that would clarify any doubts you have. Do you have any other questions? Okay, cool. So let's move on. So yeah, that's what the whole deal with time travel is, right? What's the point of making a logbook? The answer is time travel. So whenever you make a mistake, you can easily go back to that specific point in time and see what the cookbook was at that point. When I say point in time, I mean if you measure by changes, right? So if you so like you've made three changes, so to say, you want to know what the cookbook was before you made the second change. So you can check that out in the logbook. Are we clear on this so far? Do we have any other questions? Or is everything okay? All right, cool. So why let's take a slightly more real life example, right? Let's say you have a recipe for pav bhaji in your recipe book. How many of you like pav bhaji? Can we just get some representation for the pav bhaji? And I love pav bhaji, if that wasn't obvious already. Cool. Right. So why is this useful? Let's say that you have a recipe for pav bhaji in your recipe book, right? And like most people do, you love pav bhaji. So at one point, your friend suggests a change, right? In the recipe that you like, or the recipe that you've written down. So you guys are just sitting and having pav bhaji, and both of you are just talking about random things. And he says, you know what? What if we added cinnamon to this pav bhaji instead of garam masala? Or something similar like that, or maybe not such a sacrilegious example, but yeah, something like what if we added oh yeah, no, there's no love for the cinnamon pav bhaji. So what if so let's just assume some change, right, for the sake of brevity. Let's just say that your friend proposes that you add 20% sweet potatoes in the pav bhaji instead of like the original 100% normal potato. I'm not really sure because I'm not an expert. I'm an expert at eating, not at cooking, so I'm not really sure. But something like that, right? So you write it down. So you decide to maybe make a slight variation on the spices or the amount of garam masala, and you make it once and you like it because you like pav bhaji. So you write it down, and you have to change your pav bhaji recipe to make this happen. So you write it down, right? Time goes on. And like, let's say after like 3 months or so, when you've forgotten what the original proportions of the original recipe was, right? All of a sudden, your friend, the same friend who suggested this change, he says, "Look, man, I really liked your old pav bhaji. I don't know why you changed it. Why don't you make your old pav bhaji again?" So, despite not wanting to do it, you realize that yeah, your old pav bhaji was perhaps better. Maybe you added cinnamon instead of the sweet potato change, right? And your friend was not able to notice it, but you did. So yeah, so all of a sudden your friend asks to taste your old pav bhaji recipe because they're a little crazy like that. So regularly this wouldn't be possible, right? If your pav bhaji recipe was stored in like a Word document, right? And it had been 3 months since you changed it, this would not be possible at all, because you can't have seen what the Word document was like 3 months ago unless you saved a separate copy somewhere, right? And the original recipe would be lost to time. But because you used your cookbook with the logging system, it's very much possible for you to look back at what the old. So apparently, Word has version control right now. Man, I did not know that. All right, consider something like a plain, text file or a .txt file that you would open through Notepad instead of Word. I'm not very sure about Word having version control. Right, something new. I have to check that out. Either way, I digress. So in a regular situation where you use like a text file or something, this would be impossible for you to know what the state of that was 3 months ago, right? But because you have your cookbook with your logs, it's very much possible for you to look back at the old state, right? So you can visualize it something like this, right? You can visualize it as something like this. So in essence, this is what your logbook looks like if you've been keeping records correctly. You've got some description of each change that you're making, and you can just peek back at the stage that says added OG pav bhaji here. So you started off with the recipe book in the first stage where it's blank, and the first recipe you added was aloo chaat, and then you added the OG pav bhaji, and then you added dahi puri, then you added the second version of pav bhaji, and then you added rasam. So in this slightly silly configuration of recipes, the idea is that your logbook looks something like this, right? Where you can see the original state starting here at 20DFCC5. Ignore what the numbers mean right now; they're not important to the conversation here. But in essence, this is what your logbook looks like. So if you want to, right, you can essentially just peek back at the stage that says added OG pav bhaji, right? To get back to where you were. How this is implemented specifically is not within the scope of this talk, since we're focusing more on usage and trying to understand what version control is. Uh, so let's just, we're going to keep that as an abstraction for now. Are we clear till here? This is what your logbook looks like, right? You can peek back at any stage. You can move you can essentially reconstruct your cookbook to any stage you want, because you're keeping a very detailed record of all the changes that are being made. Do we have any questions? Okay, I'm just gonna assume there are no questions. If you do have some questions, you can stop me at any point, and feel free to ask. Great. So now your friend, right, the same friend who suggested that you add cinnamon to your pav bhaji, he sees how successfully you've been maintaining your recipe book, right? And he says, "Look, how about we work on this together? I want to write my own recipes as well, right?" So you hand over a Xerox copy of the extremely detailed log that you maintained to your friend, and now he's able to start his own cookbook from it. Because the idea is that from the logs you can reconstruct the cookbook, because it has a essentially has a full description of what the cookbook was at each point in time, right? So now you have two copies of logs and essentially two cookbooks. At the beginning, both are the same, but as you and your friend, uh, call him Ramesh, keeps adding keep adding recipes, the log changes, as would be expected. Are we clear till here? Do we have any questions? Any questions so far? No? Okay, cool. Let's move on. So now this is a slightly more complicated version of the diagram we saw before, right? So yeah, you can see. Sorry, someone had a question. I did hear someone say something. Please feel free to ask whatever you wanted to ask. It's fine. There's no such thing as a silly doubt. All right, I'll move on then. Great. So as you can see, the starting stage of the log is more or less the same, where you started the recipe book, and the ending stage is more or less the same, where you added the rasam recipe. But here, around the third point, you can see that there's a change in color, right? You can see that there's a separate branch, so to say, or like there's a separate split from the main line where it says added recipe for key lime pie. If you can, if you're able to like make sense of that, just raise your hand. If you're able to see this new split that happened. Okay, cool. So yeah, I hope no one's having any trouble understanding this. I'm still in the middle of explaining it, but if you guys have any doubts, please feel free to unmute and ask straight away. Great. So both of you add your recipes, right? And the logs start to look something like this in our visualization. So as you both continue to maintain different copies of the log, you both realize that one day you will need to synchronize and make the log the same. So like if someone else, say Suresh, another friend who's interested in Chinese food, wants to start his own version of the recipe book from what you guys have already written, so he can add his own recipes, he should be able to do that, right? So you will have to synchronize and collate both your logs at some point to be able to move on from there. So you both decide to merge your logs. So you guys can you guys see the purple tag at the bottom which says merge branch Ramesh here? This is my copy of the log. Raise the hand if you're able to see that. Cool. So essentially, what's happening is from here, from the first blue node, Ramesh has started maintaining his own copy of the log, where he's adding his own recipes and where he's making his own changes and stuff. So this is an and you've continued to add your own recipes. You've added biryani and golgappa. He added key lime pie and creme brulee, right? So in essence, this is what is going on when you decide to share the log with someone. There is a point where it diverges from the original, right? Which is the third node from the top, which is the last like state that you both agree on, as in like which you both decide is the source of truth for yourself. And from there, it branches, so to say, into two different branches, where your friend Ramesh is working on his own copy of the log, and you're working on your own copy of the log. So yeah, so ideally, if he's just adding stuff, you can easily combine both to make it the same thing, right? And yeah, so there's a class of problems that can occur if you both change the same thing, which is what Ashutosh was asking, I believe. What happens if you change something in the past, right? So this is a situation where it's very much possible for this to happen, right? So like, say Ramesh changes your OG pav bhaji recipe back, like the change that you reverted, where you made the pav bhaji recipe back to the original one. Uh, Ramesh changes that recipe as well, but you haven't changed it, right? So this kind of uncoordinated, unagreed upon change is called there's a very specific term for it that is merge conflict, but we'll not be exploring this in detail. I hope that solves Ashutosh's doubt that it is possible for us to run into slightly more complex problems when we don't coordinate about what changes are being made, or if we change something that was still being worked on. Are we clear on that front? If everything's clear, just raise your hand. Cool. If anyone has a doubt, please feel free to ask. I know it's like drinking from a fire hose at this point. So like, yeah, any doubt at all, we're completely fine with that. The goal is so that you completely understand what's going on. If you have any doubts, please feel free to ask. What about deleting recipes? Yes, that's also an excellent question. So, like, say you delete a recipe, right? And you'll need some way to kind of decide upon what happens when changes happen, and you both decide to merge your logs after you change them. This is usually, there are multiple techniques to do it, is the easy way to put it. There are complex procedures that go into how such a type of change is handled, which is out of the scope of this talk right now, because we just want to understand what's going on for us to be able to use Git. So this is like it's like a kind of easy run to understanding what Git does. Implementation wise, there is something that happens where it resolves where both have to agree upon one fixed state for a merge to happen successfully. I'm not quite sure about how it's implemented, but yeah, it does resolve it on its own. So like you have to decide about which is the original copy, so to say. I hope that clears it up. I know it's not a very detailed explanation, but I hope that suffices for now. All right, cool. So now you might ask me, why is this relevant? Why the hell are we talking about recipes? Why the hell are we talking about a cookbook? Why is all of this important? So here is the reason, essentially, right? In technical terms, what you maintain as your logbook and what you maintain as your logbook and your cookbook together is known as your Git repository. Git, the software Git, is the logging system that you use, to put it in very loose terms. It helps you manage your stuff, it helps you version them, it helps you work on multiple copies at once, and you'll be able to revert the whole thing back to a certain state if you want to. Are we clear on this?
Uh, can you just repeat again?
Yeah, so the recipe book, right, your cookbook, and the log that you use together are known as your Git repository, so to say. Git is like the logbook. Git is essentially the logging system that you use, right? It helps you manage your code. It helps you version it. So like it helps you decide on like we have here. You can consider each of these to be different versions of your recipe book, right? So Git helps you version all your recipes or all your code, so to say. And the recipes obviously represent the code that you work on. You can have folders, files, and stuff, and you can organize them however you want. We won't go into too much detail in that. So I hope that clears your doubt. Lokesh, is it?
Ah, yes, it's clear.
All right, cool. Any other questions? Because making the jump from the recipe world to the world of code isn't exactly too intuitively easy. So like,
Sorry, I just joined. You just explained the recipes thing, right? That's all. But,
e- yeah. So how much did you miss out on?
like, sorry, I got confused. The timings. I joined late. I no
Okay, okay.
stuff. Okay,
No,
what did you
we
just do?
do
Tell
have
me
this
the
recorded.
topic names. Okay.
We do have this whole thing recorded, so you can watch again if you want to. Like,
Okay.
feel free to just reach out to me if you have any questions.
Can you just tell me what topics you got? Like, what are the things you just said till now? That's like just the topic names.
Yeah, so in essence, what we've done is we've covered what Git is. We've used an analogy with a cookbook, like a cookbook and some recipes on how Git works, and essentially how you can handle changes that are being made, and how you can share it with other people to accept their changes into your code.
Okay, cool.
Cool. Okay.
Yeah.
So in essence, Git is the logging system. That's clear. Your recipes are your code which you write and which you will run. Yeah, so Git is, yeah, that's right, Amrita. So Git is basically analogous to the logbook that we have. Right. That's spot on. And Yeah, the last thing is your friend Ramesh, who wanted to collaborate with you on your recipe book. Could be anyone with an internet connection and a working knowledge of Git. So, for practical purposes, a very large part of the world can collaborate with you. So, yeah, the internet, the whole world, basically the World Wide Web can collaborate with you if you have a Git repository, right? That's obviously a slightly exaggerated figure, but you get the idea. There's a very large number of people who you can collaborate with. So now that we have some sort of decent understanding of what Git is, because like you guys will get a much better like a much better implementation level understanding as soon as we move on to actually messing around with Git in the command line and understanding what it does. So we'll take a small 1 minute, 2 minute break right now. If anyone has any questions, please feel free to ask them. Again, please feel free to ask questions. We have absolutely no, it doesn't matter what the question is. If you have a question, we'd like to help you answer it.
So you
So
can
please feel free to
access
ask.
any version at any time, like all the versions saved as like one by one, or like it keeps changing.
So yeah, that's kind of about how Git works, right? So you can, technically speaking, if you have the whole repository, you can access any version that had been committed, so to say. So like you saw the history tree here, right? So like with this. So if you were
Yeah.
at, so from any point you can basically revert to yeah. So this is assuming that you're making these changes yourself, but you can revert to a previous version from almost anywhere.
Okay.
I hope that clarifies your doubt.
Yeah.
Cool. So yeah. Any other questions, or can we move on? All right, let's move on. This is the first command. Let me see if I can get my. Are you guys able to see my terminal, or is it? I think I'll have to stop presenting. Just give me a second. Cool. Are you guys able to see my terminal screen?
Yeah.
Is the font size fine? Is everyone able to read it clearly?
If it could be a little larger, it would be better.
Is better?
Yeah.
Okay. Great. So the first command that we'll be covering is Git Init. What this does is it essentially starts off a new, fresh, empty Git repository in your system. So as of right now, I'm in a folder in my computer. It's empty. So yeah, we're clear till here, right? If you have any questions at any point of time, feel free to stop me. I hope that you guys will take full advantage of that. So yeah, let's begin a practical demo here by creating a new repository on your local machine. If you want to follow along, please do. I believe most of these commands are platform agnostic. Almost all the Git commands should not change if you're on a different operating system. I'm on Linux right now. So please feel free to follow along. Just go to an empty folder somewhere and like make a new subfolder or something. Just make sure it's empty. Yeah. Cool. Can we move on? what the command that we're passing right now. A good sanity check might be to see how you know if Git is installed properly. Just do git dash help, and it should show you all this. So it should say, Git version path help, all this. If you see something like command not found, it means Git isn't installed properly. But for most of you guys, it should show this when you do git dash dash help. If you guys are seeing a similar result, feel free to raise your hands. Cool. Great. Great. So this is essentially, this can be a Git tutorial if you wanted to. Like you can read this and start doing stuff yourself. But it's not, yeah. So you can do this. So what we'll start off with is Git Init. It says initialized empty Git repository in the path for this folder. And now if we look at all the files that are there, you'll notice this, which is this .git folder, right? So this is all, these are the contents of the .git folder, where it has different files, different folders and stuff. And there are a lot of hooks that you can put, which do things whenever specific actions happen. But we're not going to dive deep into this right now. It's just that you should know that there's a folder called .git present whenever you create a new Git repository. I'm going to clear the screen. So the first thing that you might often be tempted to check when you add a Git repository is Git status. Git status, I'm not really sure. Git status is the easiest way to know what repository you're on, right? So it says on branch master. So you guys remember how we talked about branches before in the diagrams, where Ramesh's branch split off from your branch, and you had to merge it later.
Yeah.
Yeah, cool. So that's what the branch system is like basically, and it says no commits yet, which means we have not added anything, and it says nothing to commit. So you remember how we had the different, can you help how to create a folder? Which operating system are you on? I believe it's Nidhi. Windows. I'm not too sure about Windows. If anyone else can help out, some of the PES open source guys, if any of you have any experience with Windows systems, feel free to pitch in.
Create a folder on desktop, just cd to that folder.
Yeah, that works too, I guess. You needn't create, yeah, I think Shreyas has an answer. Yeah. Okay, so let's move on. So Git status is an extremely handy way for you to know what Git repository you're in. So yeah, that helps you get a better look of what's going on in that repository as of right now. Cool. So now that we have an empty folder, right? Let's begin by adding something to it. So let's open say a Readme file. It's convention to create a Readme.md file. MD stands for Markdown. For those of you who aren't familiar with it, it's basically like a small. It's like a souped-up version of a text file that you can use. But that's all that basically you need to know right now. So just create a readme.txt or a readme.md file. That should be fine. Just make convention is that the readme file contains a lot of information about what the repository is, or what the project is about, what the code is about, It's good convention to keep this detailed and helpful to anyone who approaches this for the first time. What does Vim mean? Vim is a text editor. So it's kind of like Notepad, but on Linux. So yeah, I hope that clarifies your doubt.
So what are we supposed to do for Windows?
You can do edit. I think edit launches Notepad, EDIT, or just create a new file with your graphical file explorer and call it readme.txt or something, and then open it regularly like you would with any other file.
Done.
Done. Okay, cool. So this is a blank file right now. As you can see, there's nothing in the file. So how you can add a heading to a README file is to put one hashtag before whatever you write. Say welcome.
You have to do this inside the Git folder or just outside?
No, this is outside the Git folder.
Okay.
So this is outside the Git folder. So essentially, what you have to do is you have to just create a file, like wherever the same place where you did Git Init, right? The same folder in which you ran the command Git Init. In that same folder, you do not have to be inside the .git folder. Hope that's clear. Okay, so you can add anything you want, right? You just have to create a file, put some text inside it for our demonstration purposes. All you have to do is you just have to add a file, put some text inside it. It can be a text file, it can be a Python file, it can be a JavaScript file, whatever you want. Okay, so is this cool? Do we have any doubts?
I did this in Git Bash.
Okay.
And like it opened, but like after I opened this file, I'm not able to get out of it.
Oh man, did you use Vim in Git Bash?
Yeah, I think I don't have that. That's why.
Yeah, I mean, it's a very familiar struggle for anyone who's used Vim. So I wouldn't recommend using it if you're not willing to settle for a slight learning curve. But I will tell you, yeah, welcome to the world of Vim. So let's do this as well. Okay. So the easiest way to exit Vim, right, is to just follow along my keystrokes. Press Escape. Press colon, and you can see at the bottom left under normal, you can see a colon with a blinking sign. Then you have to just write WQ and press enter. That's all.
Cool, it worked. Thanks.
That's it. Okay, that's literally it. So yeah. So now if we just take a look at everything that's there in our folder, we see that it says there's a .git and there's a readme.md. Cool. So what do we do now, right? Say we've made some changes, right? So let's say we added some more stuff. I like programming. I like pav bhaji. I like eating. And you can add a I don't know, you can add a whatever, just add some content, it's fine. So like anything, just add some text about yourself, add anything you want, but fill it up with some content, and then exit from your editor, save the file and exit. Now what do we want to do? Because like we've essentially created some stuff that we need to preserve, right? So let's do Git status again to understand better what's going on at this point. Great. So can I get command of how to open the folder in Git? You don't have to use the command line. If you have Git bash, that's enough for all the Git commands. But you can use any other text editor, IDE, anything. You can use the GUI to move the files around and stuff. So you can do that as well. There's absolutely no pressure for you to only use the terminal. Okay, so you created the folder, cd into that folder, or type cd and the folder name from the command prompt, or just use your Windows Explorer to go into that folder. Yeah, the recording of this session will be available, but I do encourage you to ask doubts if you have them right now. Just feel free to interrupt me. It's completely fine. So what we're seeing right now is that it's when we run git status after adding a file, right? It says on branch master, no commits yet, the same as the previous two, the previous time we ran git status. But you will notice that here there's this segment that says untracked files. So, uh, and it's pretty descriptive, right? It says git add file to include include in what will be committed. So as of now, we need to let Git know that we've added a file so that it can track all the changes that are made to it. So yeah, and it says nothing to commit, nothing added to commit, but untracked files present. So like when we create new files or when we, yeah, go ahead.
Yeah, I had a doubt. Why is it showing README in untracked files when we have not even added README in the Git folder?
Right. So the .git folder contains a lot of the data that's there. But when you use Git as a tool, it reads some of the data from the .git folder, and it reads some of the data from wherever you're running the command from, so it can infer as to what's there and what's not.
Oh, okay, thank you.
Well, to put it in a simpler sense, Git it's not just the .git folder. It's also a tool that stores its data in the .git folder, so to say. Is that cool?
Then what is the range of the function? What? Yeah, like from where does
Sorry?
it get the information? Like, yeah.
So it basically reads the directory you're in right now. Wherever you're running Git from, it reads that directory to see which files and folders are there.
Okay, thank you.
All right. So what we have to do is now we have to notify Git that we've created this file and we want Git to track all the changes being made to this file, right? So we do git add. I prefer -a. You can do git add dot as well. So let's just do this. And usually the philosophy with tools like Git or most Unix Linux tools or most GNU tools is that if there is no output, then it's all good. Because if there's an error, it will be reported. So when you do git add -a, it basically adds all the files in the current directory except for the .git folder to be tracked. So when we do git status, again, right? We don't get the warning about untracked files anymore because we're tracking this file, right? So it says changes to be committed, and it mentions the new file as readme.md. Cool. So now what happens if we make some more changes to this? Hi, this is a new line. Cool. So we've made a change to it right now, and just ignore what's going on in the leftmost side of the screen, but focus on the text. So add a new line right now, and we'll save it and quit. And let's do git status again. So when you do this, right, it says changes to be committed, new file, and it says changes not staged for commit. And you can see that it says modified instead of new file. So I hope you guys are getting some sense of how it maintains like a history of what's going on in the folder, so to say, whenever you make changes. Is that clear to some degree? If that's complete, if you guys are fine at this point, raise a hand. We'll move on from there. Yeah, so this is basically like the non-visual representation of what it was like in that diagram that I showed you guys, like the one with the where it said added rasam rice, added recipe for rasam, added added creme brulee. This is essentially this is essentially the same thing.
It
Uh,
doesn't show whether it's modified or new file. It just shows that it's there.
Sorry.
In the sense, like on your screen, I can see new file readme, modified readme. On my screen, I can only see readme in red.
I don't think you did git add dash a. Did you do that?
Uh, okay.
Okay. Just run git status once and let me know if it works.
Yeah, yeah.
Okay,
Thanks.
cool. Cool. So now it says new file and it says modified, right? So to give you a slightly better understanding of what's going on the inside, let's run git log. All right. So git log says fatal. Your current branch master does not have any commits yet, which is what we're going to get to because we still haven't committed any changes, right? It says changes to be committed, changes not staged for commit. We still have to commit some changes. Like we still have to punch the holes in the paper and add them to our ring binder, which we haven't done yet. So now that we have this modified, yeah, it says use git add file to update what will be committed, right? So let's do that. So let's do git add dash a again. You can do either git add dash a, or you can specify which file you want to do, to which file you want to add to the tracking. Anything works. So let's do git status again. Right, and you can see it says new file readme.md again in under changes to be committed. So I hope everyone's clear up to what has happened until this point. Do we have any doubts? Any questions?
Wait, I didn't understand why you added it again. What? How did that?
Right. So you see, when we said git status here, right? It said no commits yet, which is what we expected. It said changes to be committed is that we created a new file with some content in it, and it says changes not staged for commit, which is when you modify a file, you're making a change to the state of the project, right? In essence, you're making a change to how it is. So since you've added this, or since you've basically made this new change that Git does not know about, right? Because Git knows that you have readme.md in some state. And when you do git status, it checks the current files with the state that it has to tell you what if there are changes or not. On an implementation level, it essentially checks the differences between the current state of the file and the state of the file that it has tracked. But on the surface level, that's not really important to know how it works. I hope that clarifies your doubt because we made some changes, right? We added a line to this to
Yeah.
readme.md.
Okay.
Okay, so
So well, like it
go
was
ahead,
only
go ahead.
one file, right? So why was it
Yeah, it's
show
only
new
one file.
file and modified both? Okay, it's just saying this is a new file and it has been modified.
Exactly. That's all it's doing.
Okay, and it won't. It will
Like,
keep calling it new file until it is committed. Is that
let's
okay?
see what happens. So we do git status, and we see that after that it says there are changes to be committed, and it says that you have a new file that you haven't had yet, right? So let's do git commit. This command essentially saves your entire project in one state. Okay, so when you do git commit, it will essentially add something. It'll do the punching of the holes in the paper and adding it to the cookbook that we talked about. It'll create one of the dots in that diagram. Okay, let's do when you do git commit, it's always useful to provide a commit message saying what this commit is. The more informative, the better. So you can do git commit dash m, where the dash m stands for message, and you can open quote and close quote, and you can start writing added readme md. So this is the command to commit. In larger projects, you will need to provide more detailed commit messages which is what this thing is known as. It's known as the commit message. So like you know how in the diagram we had where it said added pav bhaji, added OG pav bhaji recipe, added this, added that, stuff like that, right? So that's what the commit message is basically. So now is everyone clear on this?
So like if we don't really add A in the last step, then and if we commit, then only the old file gets committed and the changes don't get committed.
Yeah, it usually prevents you from making a commit at that point, which is when you'll have to use Git Stash, which is not really under the scope of what you'll regularly need, but it is a very useful command to know.
Okay, thank you.
All right. So perhaps in a little bit we'll see what happens when something like that comes up. Okay, so let's commit this change. Great. So git commit -m added readme.md file is the commit message. And here you can see the message that we get from Git. It says master root commit. Master is the branch name that we're on right now. And here's a commit hash. So the numbers that you guys saw right in front of each dot, that's a commit hash or a commit ID is essentially what you can think of it as. Each commit that you make or each change that you make has a specific ID that's assigned to it. I'm not sure if it's a random number that's generated or if it has something to do with the content. I'm just assuming it's a random number that's generated, and it's shown to you as the commit hash so that you can identify a commit very easily. And it says added readme.md file, and it says one file changed, 8 insertions, which is about right. So when we look at readme.md, we can see that it goes to 8 lines at the bottom here from the line numbers. You see it says one file, 8 changes, and it says create mode readme.md. So essentially what has happened is we've committed this file to our working tree or to our project. So now when we run git status, we see nothing. It says on branch master, nothing to commit, working tree clean. But when we do git log, right, we can see this detailed piece of information that you can see, right? It says commit hash, and you'll notice that the first 6-ish numbers here are the same as this here. So like it's like a small name that you identify your commit by, and it says head, which is if you're familiar with linked list or something, head is like the starting point basically, or the top, so to say. And it says master here, which is the branch we're on right now. And it says author, which is my email ID and my name. It gives you a date time along with the time zone information. And it says added readme.md file, which is roundabout what we wanted it to reflect. So in essence, what we've done so far is we've created a Git repository, we've added a file to it, and we've committed that file to the Git repository. Do we have any questions? If you have any questions, please feel free. Okay, cool. So I'm assuming we don't have any questions. So let's move on. So what Amrita mentioned was that what happens if you make a change to a file but you don't add that change, right? So let's do that. Let's go to the README file. I missed some of it. When will the recording be available? Atharva, do we have any ETA on the recording? Cool. I hope that clarifies whoever had that doubts. Cool. So let's do what Amrita said. Let's make a change. So this is a change I don't intend to commit. Cool. And let's save this file. We've added a line at line number 10. Let's do git status just to cross check, and it says modified, right? Under changes not staged for commit, it says modified. Cool. We're going to skip the git add here just to see what happens. Do git git commit dash m on tracked change. Right. So it says, so it's showing you an error, right? It says it's not letting you commit. So usually what happened the last time we did this was it showed us a success message, which gave us the branch name and what happened and stuff. But it doesn't let you do that here because you lose out on changes, right? So I hope we're clear. I hope that answers your doubt, Amrita.
Yeah, makes
Cool.
sense. Thanks.
Can you repeat the last
Yeah.
thing you said?
So when you have changes made that you haven't added to the Git has something known as a staging area where it holds all the changes that need to be made, right? So when we went here, right, when we do git add dash a, it basically adds files to Git staging area where it keeps track of what files are we supposed to commit and the changes that are being made to them. When you don't add a file to a staging area, to the staging area, and you want to commit that change, right? Git does not commit. Is that cool?
Yeah,
Are we cool with that?
yeah, got it.
That we've added stuff to our Git repo, and we've made some commits, right? I hope I'm audible. I hope I'm audible.
Can you hear me?
Cool. Okay.
Yeah.
So, yeah, we've explored Git log. All right. So now we talked about branches, right? We talked about how you can work on multiple versions of the code at the same time. So, the simplest way for you to get started is to list all the branches that are there. So and the command for this is git branch dash list, or git branch itself works. And it says star master. The star indicates what branch you're currently on, and you're on the master branch right now. So how do we move? Hey guys, am I audible? Am I online?
Yeah.
It's not audible now.
He left the meeting. He'll be
Hey guys, am I audible? Yeah, I'm so sorry. I'm having some slight network issues. I
back.
hope I hope you guys got most of what I was saying. Hello?
Yeah.
Okay, cool.
Yeah.
Cool.
Yeah.
Yeah, so yeah, that's cool. I mean, I stopped saying that right now. So great. So you guys are able to see the screen, right? Is the screen visible? Cool.
Yeah,
Cool.
yes.
All right, great. Let's just pray to God for no more network interruptions. Right. So Git branch essentially shows you all the branches that we have. And as of now, we have only one branch, which is the master branch that we're on right now. So let's say we want to, separate this out a little bit. Let's say we're working on a really important file, and we want to, keep it separate from a separation of concerns perspective, or you just want to, work on something new that you don't want to continuously have in the main branch or in the master branch, right? So what we can do is we can do git checkout dash b, and let's call it some changes. I hope the command is visible. What git checkout does, and what this command does is it essentially creates a new branch and switches to that branch for you. So the technical term itself for like that splitting off of the whole structure of the log that you guys saw is branching. So what we're doing is we're creating a new branch here where we will add some different changes that we want to add some changes to the structure of the project right now. So when we run this command, it says switch to a new branch, some changes. Just to cross check, let's run git status again. And it says on branch, some changes. Are we clear here so far? Do we have any doubts? Cool. So you can also switch to git checkout is essentially to switch branches. So from here we can go back to master if we want. We can do git checkout master, and it says switch to branch master. Right. So let's go back to let's do git status. And it says modified readme.md. What we can do right now is we can since we have changes that we haven't committed yet, let's just add this. Or how about this? Let's do the stash, right? So we can do git stash. What git stash essentially does is it saves your working directory and your index on a master branch with an ID. Basically, it saves all the temporary uncommitted changes that you've made, and it just keeps it somewhere for you to apply. So if you so let's say you have to switch a branch or something, and you have to apply those changes there. So you can do that as well. Let's do git status once. There's on branch master, nothing to commit, working tree clean. Let's just explore what happened to readme.md as a consequence of that. The line that we added at line 10 isn't there because it was an uncommitted change. Git stash essentially took that for us, and it it stashed it away, so to say, temporarily, so that we can apply that change wherever we want. Let's do git checkout to some changes. And we switch branches now. And what we can do is we can do git stash apply. Great. So now that we've done this, it's applied all the changes that we've had on our master branch to this branch. So if we do vim readme.md, you can see the 10th line here that we did. So great, let's make a commit on this branch. Can someone suggest a commit message? Leave it in the chat or unmute yourself and suggest a commit message for this. Right. Okay. So till where are we clear on what happened? We're clear till
to create another branch. Like and
so roughly from here, we created the new branch here with git check some changes, and we switched to that new branch. Okay.
Yeah.
We had that 10th line that git did not allow us to commit because we didn't add that change. We clear till that? Okay. So what happened then, right, is we switched to the branch here, where it still
Yes.
notified us that there is this change that has not been added. After that, we went back to master. We did git checkout
Yeah.
to master.
Okay.
This can be any branch name. It can be current branch to master, like it says here, switch branch to master. And then we ran git status once again to see what the situation of the branch was. Said on branch master, which is what we wanted, great. And it says there are changes that are not staged for commit. And it suggested that we add or discard the changes in the working directory. It showed us that it's readme.md that needs to be added or tracked. So what we did here is we used git stash to temporarily hold the changes that we've made somewhere, right? So git uses a technique to know the changes in files by using this technique called diffing, diffing. Diff is the technical term for it, it's the command. So git uses that to see what changes we've made to files, right? So when we say git stash, what it does is it captures all those changes and it stores them in one place. So that, yeah, like it says here, saved working directory and index state, work in progress on master. And this is the, the branch on the commit ID that we have. This is the last commit that we made. Are we clear till here?
Okay, so you saved it in stash and then you switched
Yeah, we
directory and
switched
applied the
branches,
stash
but
onto
you're
the other
right.
directory.
Cool.
Okay, got it.
So that's essentially what we did. We did git stash, we did git status again to see if there were any untracked changes. It said nothing to commit, working tree clean. And then we checked out readme.md to make sure that the change was not visible there. We checked out or we changed branches to some changes, right? And then we did git stash apply, which took all the changes that we'd stashed away temporarily and it applied it onto this branch, right? And then you
Yeah.
can see that again it says there's readme.md that's modified and has not been added or tracked. Cool.
Yeah. Good.
Okay. So again, let's just explore readme.md. This is the 10th line that we have here that we did not add or track with with Git. So yeah. So we can see that the changes that we stashed were applied onto this branch right now. Okay. So let's commit this change. Did anyone think of like a good commit message? Because that's also an important part of knowing how to use Git. So your commit messages need to be descriptive. So if anyone would like to suggest a commit message, in the chat or just unmute yourself, it's cool. This change was made in the new branch. Okay, that's fine. Perhaps a little too verbose, something shorter, something smaller. Changes from master branch. I believe the best commit message is one where you describe what changes are made. So you can say added new lines. If this is code, you would have something like added a new function or added a new class or added tests or something like that. But since it's just text, I think this will suffice. Do git commit -m, added new lines. And we have another error message here that says we didn't do this. So what went wrong here? What did we not do? What step did we miss out on?
You didn't add the file. Okay.
Yeah,
Git
that's right.
add.
That's right. We didn't add the file, right? So we have to do git add -a, and we've added the file right now. So nothing should prevent us from committing this change right now. Cool. Great. So we have a new commit here. It says some changes, and the commit hash is here, and the commit message added new lines. It says one file changed and two insertions, which is right. Since we inserted one blank line and that other extra line that said that last line toward the end of the file. So great. Now what? So now what the situation is, if we run git status, is that we have two branches. We have two branches right now. We have master and we have some changes, and we're currently on some changes, right? So what we have to do now, right? So ideally you would have many more changes than just one, but since we're working with a fairly limited feature set here, what we'll do is we'll do a merge. So we use the command git merge here to merge the master branch, to merge some changes with the master branch, like where you guys saw that that your friend Ramesh's branch was merging with yours after he made his changes. You guys remember that part, right? So yeah, so what we have to do is, the first thing now that we want to add these changes that we've made in this branch, right, to master, what we can do is git checkout master to switch to the master branch, because we want to merge it into the master branch. And all we have to do is git merge some changes. Cool. So as you can see, it says updating from this commit hash, which is the first one, I believe, the first commit that we made, to this, which is the latest commit that we made, right? It says readme.md and two pluses to see that you have two lines inserted, and it says one file change, two insertions. And we can do, and essentially what we can do here is we can do git log, right? And this is the latest commit here. You can see the head is at master and some changes, because these branches have been merged right now. And it says added new lines, and this is the first commit that we made. So what do you guys think will happen if we go to readme.md right now? This line that we had here that wasn't there, which we had removed before we committed, before we made that we had stashed off, before we switched to the new branch, is now applied here. So I mean, obviously this doesn't look like a lot right now, but essentially what you've done is you've created a new branch. You've added some code there that does not have to see the master branch at all, and you merge these two branches to create that final state. So it's kind of like when your friend added his two recipes and you added your two recipes, then both of you decided to collate the logs at once so that you can move on from there. That's essentially what happened right now. So do we have any doubts?
I tried doing git checkout master.
Right.
Yes, your local changes to the following files would be overwritten by checkout.
Right. So what line did you add a new line, or did you edit some lines that were there?
I edited some lines.
Right. So do you remember how I mentioned that there are a class of problems that come up when you try and merge two different repositories?
Yeah.
This is one of those, right? So Git needs some way to know what the truth is, because you might have added one line here and you might have deleted one line there. So Git can't really differentiate between which change it has to consider to be the more correct change, which is why, so since you're doing it yourself, right, you need to have some amount of understanding of what kind of changes will make it easy for you to merge and what kind of changes won't make it easy for you to merge.
Okay, cool. So if I do deletions, then Git won't know what to.
Yeah, so what will essentially happen is it'll overwrite what is there. So it'll consider the changes you've made in your branch right now to be the original when you select the option that allows Git to overwrite whatever was there.
Okay.
If I recall correctly. So
Okay. Okay, so I can just stash the changes and then switch the branch so that it can be changed later according to the.
I mean, which stage are you at? Are you in the new branch right now, making some changes to the file, or?
I made the new branch. I mean, I made some changes. I made new branch. I applied it on the new branch.
Okay.
Then I need to merge them.
Right. Did you add and commit?
Yeah.
Okay. And what does it say when you're trying to merge them?
When I try to merge them, it says,
You did switch to master, right? Before you tried to merge
yeah,
them?
yeah, I switched. Oh, yeah, I stored them in a stash because it was I stored it in a stash and then I switched to master. Okay, now.
It's not necessary for you to store it in a stash after you've made a commit in the new branch.
Okay, I
The
think then
the
maybe I
stash is
missed out on committing it then.
perhaps, I'm not really sure, but I do believe you have to. I don't think you need to stash it before you switch to a new branch. So if you've committed it, it should be fine. Git handles all of that for you.
Okay, I think I missed committing it. That's why it didn't let me do that. Okay,
Yeah,
I
that's
got it.
also possible. Try it out.
Yeah. Okay. Cool.
So I hope this has given you guys a slight idea of how Git works, so to say. If time permits, I think we can move on to the GitHub part. Atharva, do we have any? Do you think we can squeeze that in? Yeah. Hey, those of you guys who are leaving right now, thank you all for coming. I hope you guys learned. I hope you guys learned something useful so far. I'd welcome any feedback you have. All right, great. I just switched screens to GitHub right now. Okay, cool. Can you guys see my GitHub homepage right now?
Yeah.
Is everything visible? The font size will be a little small. I'm not exactly sure about how I can fix that. Is this better? All right, cool. So essentially, what you want to do is you want to you want to go to GitHub. You can do github.com. So you can just switch to the tab. And if you've logged in, this is what happens. So if you want to look at a repository, right? Uh, every Git repository that you push to GitHub looks like this. I'll show you guys how to do that in a second. But in essence, this is what it is. You can see all the files here. And this is where your readme.md file shows up. So it shows up here. So you can see all the documentation that you have about the repository. You'll have some instructions about getting started. You can see git checkout. Hey, you know that command, right? And other stuff. So for a practical demonstration, let's start by creating a new repository. You can either go to your GitHub homepage and click new here, or you can just go to repo.new, which will take you to the same place. So this is what it looks like when you try and create a GitHub repository. if I missed mentioning it, GitHub is basically the social network for Git repositories. GitHub is a place where you can put your code up, where people can find your code, where people can propose changes to your code, where people can explore the different types of or the different projects that are available. A lot of important work happens on GitHub. So it's essentially like the social network for Git repositories. I hope that's clear. Do we have any doubts? Okay, I'm assuming we don't. So, okay. So this is the home page of GitHub. You like if you follow people on GitHub, you can see their activity and the repositories they've started. This is my home page on GitHub. So you'll get a home page whenever you go to whenever you create a new GitHub repository, and you can add details about yourself here. You can add a photo. You can it'll show you all the repositories that you have. There's a lot of fun stuff that you can do on GitHub, and some information as well. So here are some repositories that I have on my GitHub that you guys can feel free to go and check out later. Um, so and it'll list all your repositories here. It's like every single repository that you have, it'll list it here. So you can see all the code that you have. So take for example this Git repository, which has my dot files, like my configuration files, right? You can see the branches here. You can see that there's only master, and you can see issues and pull requests, which we'll get to in a second. But what's important is that you can see the code here and you can switch based on branches that you have. Like we can go here and we can go to, we can just go here and say this repository. So like it says 4 branches here, right? So you can switch to different branches, and you can see perhaps this branch where you can see a slightly different version of the code, and it will show you the commit hash here. So I hope you guys are able to make the mapping to what Git is and what GitHub is. If you guys have any doubts, because like GitHub is essentially like uh, apart from the social network analogy, it's like a front end for your Git repo that you can put on the internet. How it works on an implementation level is again out of the scope of this talk, but we will show you how to push a Git repo to your GitHub account. So are we clear till here? Cool. And you can see that it says this branch is 4 commits behind master. So it gives you all sorts of useful information. And if you do compare, right, you can see all the differences here in terms of what has been removed, that's highlighted in red, what has been added, that's highlighted in green, and yeah, you can see all this stuff. So do check out some popular repositories and try and explore yourself and try and understand how it works. But for now, we'll be just creating a new repository. So again, you can go to here and you can say new repository, or you can go to repo.new, which is, I'll just put that in the chat. You can go there and it'll take you to the page where you can automatically create a GitHub repository. I hope all of you have created GitHub accounts. If you haven't created a GitHub account, raise your hand. Okay, that's awesome. So cool. It says create a new repository. And like it says here, a repository contains all project files, including the revision history. So you can start your repository with a template. There are certain types of repositories known as template repositories, but we won't go into that right now. What's important is here, right? You can either, okay, so you can start off by giving a repository a name. So let's say this is a GitHub, or a Git presentation, right? Okay, Cool. So we've given it a name, and GitHub lets us know that this name is available. That's good. We're going to skip out on filling in a description right now because you can do that later. And here you can see that you can make a repository either public or private. So private repository means you can control explicitly who sees the code or the data inside this repository, and the public repository is open to anyone. It's like if they have access to GitHub and they know your username, they'll be able to see this repository. So let's make this a public repo for now. And you see some options here that say initialize this repository with, which we're going to skip out on because we already have this repo. So skip this step if you're importing an existing repository. And we are, because we already have a Git repo in our machine here. So we'll skip out on that. So we're not going to choose any of these, and we're going to create a repository. Now what this does essentially is it creates a remote version of Git on GitHub servers, where it's going to be able to mirror the repository that we have here. This is done by setting up something known as an upstream repository, which again is a lot of the technical bits of it are out of the scope of this talk, but this is enough for you to know. This is enough for you to get started with using it. So every GitHub repository has a URL. You can see a URL here, https://github.com/Anirudh Rowjee/git presentation 2021-pesos.git, right? And we have some option, and this URL is unique to every repository that's there. So we have a few options here. It says create a new repository from the command line, or push an existing repository from the command line, which is what we want to do, right? Cool. So I will now, let's just copy this command, and I hope the terminal is visible right now, or are we still on GitHub?
We're still on GitHub.
Okay, just give me a second. Just give me a second. I seem to have some small issues here. Cool. Are we able to see the terminal?
Yeah.
Okay, cool. So now that we're just need to make sure that we're in master, so we do git status. Right, it says on branch master, nothing to commit, working tree clean. Great. So in this sense, it's what we have to do is we have to copy paste this command, which is git remote add origin. What this essentially does is it tells our Git repository that look, there's another Git repository somewhere that is going to mirror what happens here, or that we're going to consider as an upstream repository, so to say. So we want you to be able to send code to this place, right? We do git remote add origin, and the same URL that was provided to us by GitHub, which is https://github.com/Anirudh Rowjee/git presentation 2021 pesos.git. So that was the URL you could copy, right? And we essentially call this the origin in this terminology. Is everything clear up till here?
Yeah.
Great. So let's do this. And no output, so assuming everything's good. We have nothing uncommitted because we did git status and it says on branch master, nothing to commit, working tree clean. That's great. Now what we have to do is we have to push all these changes that we've made to the GitHub repository. So we do git push -u origin master. You can push a specific branch as well, because usually the case is that when multiple people are working on a project, everyone basically assigns themselves a branch to work on a specific thing, and you don't have to push the whole project, right? You don't have to push the whole thing if you want to push just the changes you've made. Push is the command that sends your data from your GitHub repository here to the upstream origin repository on GitHub. So you can push any specific branch that you want to. Right? So you say git push -u origin master. When you do this, it'll ask you for your username. So let me just provide my credentials. It'll ask you for your username and password. And we have some output here. Great. So let's just, so this gives you a slightly more internal look into how Git works, where it says enumerating objects, all the different things that are present, counting, delta compression, compressing objects, writing objects, even I don't know what this part means actually. Delta, I believe, is the changes, and it says remote resolving deltas. There are things that can go wrong in every single specific step, but like most of the time nothing goes wrong, so you should be fine. This is from the remote end, so it's just checking what changes have happened, and since there's only one change, it's pretty easy. So it says to https://github.com/this URL. It says there's a new branch that's created called master, and it says the branch master is set up to track remote branch master from origin. So we've kind of established a connection between the two repositories here, between the repository on GitHub and our copy of the repository here. So is everything clear till here? Let's just go back to GitHub and see how it looks. Please feel free to ask any doubts if you have them.
So the one on GitHub is considered as the origin?
Well, usually what you have on your the origin is the name we've given it. You can give it any name you want, but usually when you're working with multiple people, right? Since most of their changes will go to the GitHub repository instead of being on their local thing. Once they've made the changes on their machine and they push it to GitHub, in most cases, GitHub is considered to be the origin repository, or like the prime source of truth, single source of truth.
Oh, okay.
Great. So this is where we left off the GitHub screen at, right? I hope it's visible to everyone. I haven't refreshed it yet, but when you do refresh it, this is what happens, right? You can see the you can see the repository here. We have a URL, so I'll just copy paste this. You guys can check it out if you want to. Right. So I'll copy. So yeah, this is what happens basically. So you can do this, and you'll see the same thing. You can see one branch that's master, right? And like when you push another branch to a repository, that shows up here. But since we haven't pushed any branches except for master to the repository, it's not showing up. And you can switch between branches here if you want. You can see the one file that we have, right? It says welcome to the Git workshop, all the stuff that we added, and it shows us the latest commit hash, right? And it says 24 minutes ago was the last change that we made. It says 2 commits. So when we click on this, we can see the 2 different commit messages that we had with the commit hashes, just like we had it in the command line. And you can see and it says browse the repository at this point in the history, which is exactly what we were talking about when you wanted to refer to it before, right? So yeah, you can do this. And obviously this is the final state, but if we want to, we can step back a little bit to the initial commit and see what it had, where essentially the last line is missing. So we've essentially done time travel at this point, which is awesome, and we all should congratulate ourselves. But in the simplest sense, this is how GitHub works. It's a place where you can throw your code onto the internet where other people can see it. So the last, I hope this is clear. For the absolute last bit of this talk, I know we're about 15 minutes-ish over time, but this will take another 2 minutes. So for like the absolute last bit of this talk, what I'm going to do is I'm going to take one of the PES open source repositories, and let's see if I can make some changes to it, right? So this is the PES open source GitHub page, which you guys can, I'll leave the link to this in the chat as well. So if you want to contribute to any projects, you can do that here. So you can do this, right? And these are all the projects that are there in PES open source. So let me pick one. Let's pick an old website or an old repository. Or let's just do members list. No, I think I've forked that already. So let's find a repository that I haven't touched yet. Let's do psopensource.github.io. This is PS Open Source's website, the code for which itself is on the PS Open Source GitHub. So now when you want to start working on a project from GitHub, the first thing you need to do is you need to fork the repository. And I've already forked this, so I can't really use this one. Atharva, do you have any suggestions on a project on an old project that I can fork right now? Right.
So is it,
I think we can do this. Meetup reports. Let's just make the 2021 folder. Okay, so yeah, great. We can do that. So guys, so what's happening right now is that I've come across a GitHub repo that I want to contribute to. The first thing that I need to do, right, is I need to fork this GitHub repo so that I can create a new branch and add changes to it. So let's just hit fork here, and you have to choose your own account. So what forking does is it's basically creating like your own personal copy of an open source repository. Great. So as you can see, it says this repo is my username and meetup reports. And it says forked from PS open source /meetup reports. So the first step for me right now is to clone this repository onto my machine. You can see that you can click on this and it says it gives you the URLs that you want. So you can copy this URL. And let me just switch back to the terminal. Okay, so I hope you all can see the terminal now. So I'm in a folder where I can clone this project. So all I have to do is git clone. I have to put this URL here. What git clone does is it basically downloads the entire Git repository from GitHub or from any other place like GitHub or like GitLab perhaps or Bitbucket, and it puts it on your machine. So let's just see what happens when I run this command. It says cloning into meetup reports. From the remote repository, we see all this log information, and over here it says unpacking objects. So if we do an ls-la here, we see meetup reports as a folder that has been created here. Let's go into that folder. And this is essentially the contents of the repository that was there, right? So we had a 2019 folder, we had a 2020 folder, we have a .git, and we've got a readme.md. So let's just see what's going on. Let's do git status. There's nothing here. Let's do git log. And when you do git log, you'll often get a lot of output, which is not really necessary for us to consider right now. But just to show you what like an actual repository's output looks like, where multiple people are contributing. You see Atharva here, we see Siddhant here. I believe both of them are on call. Yeah, so this is what it looks like. So you have different commits from different people identified by their emails, identified by their names, identified by the different date times. You can see a bunch of commit hashes. All of this is not relevant to us right now. All we need to do is we need to see which branches are there so we can create a new branch and we can start contributing to it. So git branch, and there's only master. Great. So let's make a new branch. Let's do. Can someone tell me what the command for creating a new branch was? If anyone remembers, just leave it in the chat. So it's git checkout -b add 2021. So this is the new branch that we're adding. And it says switch to a new branch, add 2021. Great. Let's do git status just a cross check. Nothing to commit, working tree clean. So I can start by creating a new file. I can say make a new directory 2021. And we can add a new file. So we can say vim 2021 / github git and github workshop .md. I believe it's a markdown file. Not really sure. Atharva, is it a markdown file or is it text? Well, let's just look it up. Let's do tree. Oh yeah, the markdown files. Cool. So right. So we can do vim. We have to make another directory. Oh no, it's fine. So let's do vim 21 / git and github workshop .md. This is a completely new file, right? So it says git and github workshop conducted by Anirudh Rowjee. Peak attendance 50. Cool. This is it. This is the only file I'm adding for the sake of brevity. So let's save this file and quit. Now we can do git status. And it says untracked files. Let's just do tree to see. And we can see that under 2021, this file has been added. So the next step now is to do git add -a. All files have been added. Let's do git status. Right. So it says new file 2021 / git and github workshop.md. In a real world project, you would have to spend a lot more time making changes. It won't be as easy as this, but the procedure remains the same. You have to fork the repository, you have to clone it to create a new branch like I have here. It says add 2021, right? And it says, and commit your changes basically. Great. So now what we have to do is we have to make sure that we don't merge the changes here because the merging has to happen on the remote repository. So we do git push -u origin, which is what we're doing right now is since we've not committed this yet, right? So we have to commit this first. Git commit -m added git and github workshop details. So we've committed this right now. If we tried to push it before, that push would have failed. So we can push it now. So we can do git push -u origin. What's the branch? 2021. Great. So now since I've forked this repository, right, I am allowed to make a new branch and push changes to it. So I can say username, Anirudh Rowjee, password. This is great. So going by this, the push has been successful. And now it tells us create a pull request for add 2021 on GitHub by visiting this URL. So let's do that. Let's go to GitHub and let's create a pull request. All right, so can you guys see the GitHub screen? On
Yeah.
here, basically what it says is GitHub is notifying us already because like that change was made in the background, right? So it says add 2021, a branch, right? Which you can see here under branches. It says had recent pushes less than a minute ago. So it says compare and pull request. Pull request is basically a request asking the repository owners to allow you to make changes or to allow you to make your proposed changes that you made in a Git branch to and put it in the main repository. When you say compare and pull request, it takes you to this screen, and you can see that it tells us that it's able to merge. So sometimes this won't happen if you're not communicating clearly on what changes you're making, and you'll run into what is called a merge conflict, which we mentioned before, right? So thankfully, these were able to merge this, and it's good practice for you to provide a very detailed description of the changes that you're making. And they'll usually have a format that you have to adhere to when you're writing these messages. So I can just say hi. Hi, I have added the details for the Git and GitHub workshop. Thank you. You can say this, you can upload pictures, you can write this in markdown basically. So you can put a hashtag here if you want. And you can and the next step right now is create pull request. So what happens now is that whoever is the repository owner, right, will be able to see that you've created a pull request, and it opens up a conversation where you both can talk about the changes that you're making, where they can approve or disapprove of your changes, and essentially if they're fine with it, right, the first step is that it has to be mergeable. So it says this branch has no conflicts with the base branch, and we can merge this pull request. So what the maintainers have to do, or the people who own the repository now have to do, is they have to approve it. You can leave some more comments here saying this was a nice experience, and you can add a comment. You can add some reactions and stuff to it. You can add a smiley. You can add a thumbs up, and you can. So essentially, what has to happen now is that the maintainers have to go and they have to approve this change. So once they do that, the merge will happen in the remote repository, and it will reflect here. So when you go to the original repository and you see that there's a pull request here, once it's merged, you'll be able to see the code changes reflected in the master repository as well. This is usually out of our control and has to be done by the maintainers. But yeah, that's about it. So if you guys want to, you can actually go ahead and clone the repository that I've made for this. You can each make your own branches and add some new file and add a couple of lines to it. I wouldn't suggest adding lines to the same file because that would cause a lot of problems. Like just add like a new file with your name as the file name and your SRN maybe to add some more uniqueness to it. Write a little bit about yourself and maybe open a pull request. I hope you guys have learned enough today to be able to do that. So yeah, that's about it for this talk. Thank you guys for staying here. Sorry?
What's the first command you did after you forked it?
Git clone.
Okay.
Let me just type that out. Okay, yeah. So thank you guys for attending this talk. I mean, yeah, there's a feedback form that you guys can fill. Thank you guys for attending. I think we can stop recording now.